Good morning, everyone. Thank you for joining today's Resideo webinar session where we are going to provide an overview of zoning. My name is Jamie Quanrood and I'm part of the Resideo Sales Training Team. And on behalf of all of us, I'd like to welcome you to our training session today. Before we get started with our zoning technical presentation, I'm going to cover just a few administrative items. Every week, we give you 2 opportunities to join us and learn about our products. Please join us every Tuesday at 2 p.m. Central Standard Time and every Thursday at 11 a.m. Central Standard Time. For a schedule of our future webinars on a variety of topics, please visit resideo.com/webinars for more information. We want to make sure that it is easy for you to find the schedule for our upcoming webinars and also the recordings of these previous sessions as well. So on the website that you can see on your screen, we have added the ability to sort by business type. And we have sorted here by the comfort business, which brings up all the webinars that are offered in May for our customers for your viewing. Additionally, as I mentioned, we are recording each of these sessions, and these sessions are posted on this website for your reference at a later time. For those contractors joining us for today's live session and you are interested in earning 1 NATE continuing education credit, there are just a few things to note. If you provided your NATE ID on your registration form, we submit that information to NATE for your attendance of today's live session, and we don't need any additional information from you at this time. If you did not provide us with your NATE ID on the registration form for this webinar session and you'd like to receive credit for attending today's session, we ask that you email your first and last name, your NATE ID, and the date of the session you attended to homes.university@resideo.com within 1 week from today. We do submit this information to NATE 1 week following the close of today's session, and any requests that are sent outside of 1 week from today's live training cannot be processed. As a reminder, we can only process requests for NATE credits when you attend the live webinar sessions, and we are unable to process requests for watching a recorded version of this session. For more information about the NATE program, please visit their website at www.natex.org. And one quick note before we begin our zoning technical presentation today, all attendees are muted. However, if at any point during the technical presentation you'd like to ask a question, and we do welcome questions, please use the Q&A feature that is found in your Zoom webinar controls. We are going to reserve the last 15 minutes of our time together today to answer any questions that you do have. So as we progress through the technical training today, please be sure to ask your question in the Q&A feature so that we can address it at the end of today's session. Now we're going to turn things over to Frank Krigler, who is a contractor development specialist in Illinois. Frank has been in the HVAC industry for 38 years, and the majority of that time he was the owner and operator of a contracting business where he designed hydronics and zoning systems in the Chicago market. And we're very glad to have Frank here today sharing with us his zoning expertise in today's training. Frank, the floor is yours.
Thank you, Jamie, and welcome everybody to our zoning class part 1. We are also going to have a zoning class next week on zoning applications and accessories, so please join us then. We will delve in a little bit more. This is a intro to zoning. This is what we offer. You've got ARD, ZD, EARD, and then our zoning panels. The number 1 complaint of new homeowners after 1 year of living in their home is uneven temperatures in their house. I have to tell you, I've done a lot of zoning systems and I met this guy quite often. I just paid in the Chicago area, it's between $1 million to $10 million. And they get upset when their heating and cooling doesn't work properly. I've met this guy a lot. If the ducts are accessible, you can zone it. You can use ZD dampers on the trunk ducts, RRDs on the branch ducts. We'll get into that a little bit further down the line. Typically in a house, your thermostat is on a 2-story house anyway. Thermostat is generally located on the first floor, living room, dining room, hallway. And typically you're gonna have it at 72 degrees. You're gonna get, in this slide, 8 degrees of rise, but in practical sense, it's more like 10 degrees of rise. If we zone it, we can have even temperatures throughout the space. Rules of thumb. Typically, we divide the house into daytime and nighttime zones, or upstairs, downstairs. I like to do it by load. Always look for rooms above a garage or a master suite. That's where the homeowner likes to be the most comfortable. Above a garage, you generally have more of a load. Always avoid zones less than 25% of the total load. If you do have small zones, we highly recommend that you use 2-stage equipment. If you are doing zoning, you should offer upgrades. It's just a smart thing to do. An example of a layout, you've got your daytime, nighttime, and home office. Why Resideo Honeywell Home? Well, it's a brand name that homeowners know and trust. We have the highest quality systems. You've got your builder grade, HZ221, HZ311, and then you've got your plain language setup, the HZ322 and the HZ432. Let's be honest, if you're going to differentiate yourself, you're going to be doing zoning because it will increase your profit margins. We also offer a complete lineup. We have the thermostats, panels, dampers, and system kits. This is what you want to do. Offer customers comfort. And it's energy savings. Everybody wants to be energy savings this time of, we gotta face it. Everybody wants to be eco-friendly. Only heat and cool the rooms you use, and we have energy savings when programmable thermostats are used. Here's what you need. For every zone, you do need a thermostat. You can't use one thermostat, 4 wireless sensors, and expect to do 4 zones. Then you need a zone panel kit. Now, why do we say a kit? We'll get into that a little bit more, but we always recommend a kit because you get all the pieces and parts that you need to make this work properly. Then you need the zone dampers, and a bypass damper is strongly recommended. We'll get into that a little bit later too. Here's our zone panel layout: 311, 221, 322, and the 432. We use push-in terminals, makes it easier to wire. LEDs for the zones, when they're turned on, you can see which zone is on, whether it's calling for heat or cool. We also use thermal protection, which means circuit breakers. So if you have a dead short, and I've had a lot of contractors call me up and say, my panel doesn't work because every time zone 1 calls, the panel shuts off. Well, we would go out and find that they had a dead short on that zone. When the zone would call, it would go into protection, so it goes to sleep. When the short is repaired, the zone panel worked perfectly. We also have variable speed control. Now you have to have a furnace that has 2 speeds available. And I'm not going to mention brand names, but typically if you see a dehume on a computer board for a furnace, that's where you would use this terminal. It is a 24-volt output, and it'll run the fan on low speed when only one zone is calling. Runs the fan on high speed when 2 or more are calling. I really like this. You can mount it on a 2x4 wall. Our panels are only 8 inches wide. Why do we say a 2x4 wall? Well, typically on a zone panel, you'll only see screws on the corners. You'll also notice that in this diagram, we have Phillips head screws. Typically, our installers have 1/4 inch nut driver bits. Now, our panels are designed for the installer. A nut driver bit will fill in that hole, and they won't have to get out a screwdriver and struggle with mounting the panel. A very good feature. Easy wire routing. You can run the wires from the top, bottom, sides, or from behind, as you can see on the right there. And most people don't realize that we actually put in wire tie anchors, which you can see right here. That's for wire ties. Intuitive. Makes your installation look neat. Also doesn't let little kids pull the wires out. Zone panel kits. This is what comes with a zone panel kit. You get the panel, you get the proper 40 VA transformer, and you get a discharge air temperature sensor. Highly recommended. Should always be buying a kit. Just add the thermostats, the zone dampers, and the bypass damper. More on that later. How reliable? Well, this melted panel is in our learning center in Golden Valley, Minnesota. I was told that this was turned in for warranty. Problem was, this still worked. Again, best in class circuit breaker protection. And you'll notice all the little points just outside the wiring, those are for voltmeter probe troubleshooting. Use virtually any of our thermostats. You can also use others' thermostats. I'm not going to talk about too many here. However, you cannot use a power stealing thermostat. Again, I'm not going to mention any names, but if you have a thermostat that power steals, our panels will go into shutdown because they will feel like it's a dead short. How many dampers can I use? Well, the max is 4 per zone. With a 40 VA transformer, you'll notice you can use 5 per panel. If you up the VA voltage amps, you can use 11. You see on the right side, the RRDs, which is retro round damper, you can use 12 per zone with a 40 VA. You can only use 12 per zone with a 75 VA, but if you do the math there, max per panel is more than double. The reason for this is an RRD is a 3-wire instead of a 2-wire, requires less voltage amps to drive the motor. The HZ221. Now, I'm in the Chicagoland market. We typically don't use heat pumps. In my market, this is a panel for heat pump only and auxiliary heat. 2 heat, 1 cool, 2 zones, no configuration. You still do want to use a discharge air temperature switch. It does not do dual fuel. So if you have propane, gas-fired furnace, this will not work with that. Again, this one is not configurable. It defaults at high temperature of 160 low temperature of 40. The HC311 is for a gas furnace with AC, 1 heat, 1 cool, up to 3 zones. No configuration at all. Again, we highly recommend using a discharge air temperature sensor. However, the calls I got yesterday when it was just touching 70 degrees and the contractors are out installing furnaces still, they call me up and they want to know why the air conditioning will only run for 10 minutes with an HC311. Well, when it's only 70 degrees, it doesn't take too long to hit 40 degrees on the low side. So, got to keep that in mind. If you're dealing with a Unico system, you cannot use this panel because 40 degrees is just not low enough. Believe me, I learned that the hard way on an installation in an attic, very hot, trying to figure it out. So 40 degrees is the low with the HC311. HC322, furnace, AC, or heat pump. It's 2 heat, 2 cool. Again, 3 zones. It is an intuitive menu-driven setup. Standardized checkout, which means that when you commission this panel, you can check out your zones, you can check out your heat cycle, you can check out your cool cycle. Understand when you do a checkout though, you are bypassing safeties. So you want to be careful when you're doing a checkout. It is RedLink enabled, which means it will do wireless thermostats. However, to do RedLink, you will need to install a THM4000R to operate anything wireless with RedLink. And with a C7089R, you can use wireless outdoor sensors. This panel does not do dual fuel. This is our Mac Daddy, the HC432. I love this panel. Furnace, AC, or heat pump, 4 zones. This panel is configured to do dual fuel, 3 heat, 2 cool. Again, intuitive menu-driven setup. You do have to set these up. Standardized checkout. Again, when you're commissioning, you can check your heat, your cool, your fan. It is RedLink enabled. You do again need the THM4000R to do any RedLink. This is a great panel because you can have this panel running a heat pump, use a standard thermostat, and it will do the conversion for you. As you know, on a heat pump, you're only doing Y1, Y2. If your thermostat's calling for W, this panel will convert that and call your heat pump. This is a great panel. This panel will also stage for you. If you have a standard thermostat and the homeowner likes it and you don't want to change it, but you put in a multi-stage furnace, you can run your staging by time or percentage of zones. Percentage of zones means if only one zone is calling, this panel will only stay in low stage. When more than one zone is calling, it will kick into high stage. Why do you need a discharge air temperature sensor? Well, of course, to prevent coil freeze up or to hit high limit. Typically, furnaces today, if you hit high limit 3 times on a call for heat, which if only one zone is calling and you don't have a discharge air temperature sensor, you're going to hit high limit. And if you hit high limit 3 times in a call, it's a manual lockout, which means that your homeowner has no heat. If that happens on a Sunday night and Mrs. McGillicuddy doesn't want to go in the basement because it's scary, you have to go out there. always set your discharge air temperature sensor 15 degrees below the high limit. So you have to do a little homework here. The reason for that is if your smallest zone is calling and your discharge air temperature sensor goes off, it's going to click out the burners. On a clean furnace with a clean coil and a clean filter, you're going to get 8 degrees of rise. As your filter gets dirty, that rise is going to go up. Typically, when you've got a dirty filter, you're going to get 12 degrees of rise. Now, if you have a plugged filter, you're actually going to want this to go off, because that's when you want to get out there and do the maintenance. And again, it defaults, the panels default at 160 and 40. So if you're doing high static systems like a Unico or a Space Pack, you're going to want to go to the HZ322 or the 432 so you can make the adjustments. It is adjustable. Our panels are adjustable in 5-degree increments. Now, this is a little controversial, and our installation instructions, this is where they tell you to put the discharge air temperature sensor. Now, in my market, in the Chicagoland area, typically we have plenums that are in the basement that are on average 24 inches high. I like to tell customers, install the discharge air temperature sensor at least 12 inches above the coil so you don't get the radiant fallout, but you're in the main airstream. This is typical of my market. My market may not be your market, so always reach out to your local reps for help in this matter. We are all across the country and Canada. We're all ready, willing, and able to help you design a zoning system. Always remember, it should go before the first damper, and it prevents coil freeze up or high limit trips. This is not typically used in my market, but if you have an air handler with a heat strip, we highly recommend that you put it between the A coil and the blower. Heat strips will cause a lot of false readings from radiant heat, and it will tend to short cycle your system. So this is a very good slide if you're in a market that you use electric heat strips. So red link zoning, the things we can and cannot use. If we have a THM 4000, we can use an outdoor sensor, the portable comfort control, or a gateway. At this time, we cannot use an equipment remote module. We cannot use wireless indoor sensors. Now that's with wireless red link. That's not to say that if you're using an EIM board, you can use a wireless indoor sensor. There are different applications, and we'll go over that in next week's training. Selecting dampers. Here's the different dampers that we offer. Automatic round damper, generally residential new construction. Size ranges are 5 inches to 20 inches. We have the ZD, which is rectangular, 6x6 to 20x28. Always remember, when ordering a ZD damper, the actuator is on the second dimension. This is very important. If I call Billy Bob at a distributor and I say, hey, I need a 24x8 bottom mount, and he writes down 24x8, it doesn't matter what he puts down after that, you're going to get a side mount because you called it out improperly. If you need a bottom mount, I need an 8x16, that's a bottom mount. 16x8 is a side mount. The RRD, or retro round, for retrofit, 5, 6, and 8. The MARD is typically for light commercial, anything over 5 tons. And then we have our CPRD, which is constant pressure relief damper. This is for our bypass. 8, 10, 12, and 14. We'll get into that a little bit later. As you can see on the ARD and the ZD, the actuators are actually identical. The EARD is an exhaust damper. So the ARD and the ZD are power closed. The EARD is power open. So if you're doing forced air zoning and your damper actuator fails, you want it to fail in the open position. Typically, if you're bringing fresh air in, you want it to fail in the closed position. Here you can see our old, this is more like a zone motor on the left. The big long screw is what the indicator was for open or closed. You can see on the new actuator, which is 2014 to present, you can actually see whether the actuator is in the open position or the closed position. You can also notice the red little dot on the top. That's your bleed rate, and we'll go over that a little bit later. So here we have the M847D, which is your zone and your vent. Red means exhaust, black means it's for forced air. And again, it's easy viewing to see where the actuator actually is. Bleed rates on a EARD are for how far it will close. And the zoning actuator is for, again, its bleed rate. So it won't close all the way. This is our range stops. 0 is fully closed. 1 is 17%. 2 is 30. 3 is 50. I would typically never go into 3. The usage for range stops is if you have a small zone, let's say you have a 3-zone system. You've got 1 small zone and 2 large zones. So I've got a 20x8, a 24x8, and a 12x8. On my 24x8, I can put a bleed rate of 1 or 2. When my smallest zone opens, I'm still going to get some bleed rate, which gets me lower static pressure on startup, which keeps me from hitting my limit on an ECM motor. More about that when we get into the bypass. So our old to our new, we've got a much shorter set screw. The old set screw was the actual indicator for whether our damper was open or closed. There's no need for that now because you can actually see on the end of the actuator whether it's open or closed. This allows for when you're in the southern district and all of the insulation or all the ducts are insulated, this makes it a lot easier to insulate right up to the actuator. It won't tear your duct insulation. old to new, they're backwards compatible. They fit on our old dampers. If you come across the old style that the gears are stripped, all you got to do is unscrew that set screw, slap on the new actuator, rewire, and you're done. Now, this gives me a good time to highly recommend to everybody that's installing bottom mount dampers. When you're installing a bottom mount damper, it's good practice to always check whether your set screw is tight. I hate to admit it, but there are dampers that are manufactured on Mondays and Fridays. They are, and occasionally they don't torque them correctly, so good practice to always check them. You don't want to come back 8 months later and have an actuator laying 2 feet from the duct. RRDs, I love RRD dampers. We actually ship them with a decal that you peel, stick. You take a drill, open a little hole, cut a 1-inch slot, 10 inches long, stick this in. We ship it with the screws, 4 screws, wire it, and you're done. Fraction of the time, you don't have to take the ductwork apart. This again is for branch ducts, and I assume if you're doing high efficiency or high velocity, you know, I've actually zoned Unico systems with RRD 8s. This damper works really well with that. MARD, again, this is a light commercial. Comes in sizes of 5 to 18 inch. It is power open, power close, low leakage. It is a 3-wire installation. Typically, this is for systems over 5 tons. CPRD, this is for bypass. Now, you really want to use bypass when you're dealing with the ECM motor, because ECM motors have a safety in them that if you go above 1.5 static pressure, that blower motor is going to think your coil is freezing or your filter is plugged, and it's going to ramp up to 2.0 for the duration of the call. Now, in my market in the Chicagoland area, I quite often get calls from contractors that say, your zoning is terrible. Every time this thing calls, it sounds like a jet engine. Typically, I will go out and they size the bypass wrong. When the bypass is sized properly and you start up, your bypass is going to open, your motor is going to get past startup, and then it's going to ramp back down. Your bypass is then going to close. This is typically where we install a bypass. A lot of our rules are there for protection. Typically 6 feet from a blower motor just means that if you're in a heat mode and your bypass is open, you don't want to overheat your motor. And again, the discharge air temperature sensor, they are in a shaded area. This is in our installation manual. I personally, in my market, do not recommend it. However, again, I would caution you to always call your contractor development specialist to help you with your zoning design. We're there to help. The CPRD, the bypass damper, comes in 4 sizes. It is dial set, so easy peasy. You will dial this to the static pressure you need. Typically, it comes set at 0.05, and for 95% of your installations, this is going to be the correct position. You want to call your system with your smallest zone, make sure that your bypass opens. When you call your entire system, let's say you have a 3-zone system, you want to have your bypass closed when all those zones are calling. So the difference between the old and the new, the SPRD had to be mounted level and horizontal, or it wouldn't work properly. There was a way to adjust the weight, but in our installation manual, it did say it should be horizontal and level. The new CPRD, well, 2012, it's still new. But this is a great bypass damper. So when you look at these CFM ratings, this is not typical of standard ductwork. And I can explain that in an easy way. We are dealing with smaller duct, or smaller, typically you're going to have 2 elbows and a 5-foot piece of ductwork. So you're going to be running at a higher static level, which means if you go to a duct chart or a ductilator, that you're not going to see 8-inch get up to 600 CFM. But if you increase the static level, you will see it. So an 8-inch can do 600 CFM, 10-inch is 600 to 1,000, 12-inch is 1,000 to 1,400, and the CPRD 14 is up to 1,700 CFM. Now, typically, if my smallest zone is 600, you can see by the math on the bottom, if I have a 5-ton system, 2,000 CFM, smallest zone, 600, the bypass needed would be 1,400. Now, the caveat to that is you can also use bleed rate in your configuration. So if I have bleed rate on 2 zones and my smallest zone is 600, I'm able to get away with maybe a CPRD 10. So there are ways to get around if you don't have room to do a CPRD 12, but you know you need one. If you do bleed rate, you can go down to a 10. To adjust the CPRD, you simply pop open the crank and adjust it as needed.
Thanks so much, Frank. We appreciate you walking us through that zoning overview. You can find information on the zoning products that Frank covered today during our technical presentation at the new Resideo.com website, which is featured on this screen. We are going to transition to answering a few common questions that our sales reps get about zoning. And then we're going to move on to answering questions that have been entered into the Q&A while Frank has been giving us his technical presentation. And just as a reminder, if you do have any questions on anything that was reviewed today, please take a few moments and enter that information into the Q&A feature in your Zoom controls. And we will do our best to address your questions in the time that we have remaining today. We are going to have Chuck Rose, who is one of our Resideo contractor development specialists in the Georgia market, join Frank to help answer your questions and go through some of those common zoning questions as well. So welcome, Chuck.
Thank you, Jamie. Frank, would you like to take the first common questions, or would you like me to take them?
No, I can take them. Can you hear me okay?
Yep.
Yeah, aside from bypass damper, are there other methods of reducing pressure in a zone system? Well, as we covered on a previous slide, you can use the DSBK terminal to lower the fan speed when only one zone is calling. Can I control a humidifier, dehumidifier, or ventilator with a zone system? Now, Chuck, I know you have probably a better answer on this than I do because you're in the Georgia area and you typically get this question a lot more than I do. You want to take that one?
Yeah, absolutely. So the answer is most certainly you can. We don't typically see a need to have separate points of control for a humidifier, dehumidifier, or even a fresh air damper throughout a home. It's a little different. It works a little differently than the temperature controls. So our recommended method, and what works fantastically in my market, is to use one of the thermostats in this system to control your IAQ equipment. And doing this, there's several ways to do it. We do have some red link thermostats that can be operated with equipment interface modules if you don't have enough wires or any wires in the zone where you want to control it. And then of course, most of our or all of our IAQ thermostats have U terminals on them that can be used to control an IAQ piece of equipment. Doing this allows you to have one point of control for the IAQ equipment, and typically those are set up so that you set them to maintain a certain humidity level, and then you just really forget them, and so they kind of run. And then the process of humidifying or dehumidifying the house will naturally cover the whole house. And the exception to that would be exceptionally large houses. In those situations, we do have other ways of controlling multiple units throughout a house. But those are kind of specialized. So again, I'd refer you to your contractor development specialist, and I would say reach out to them. They are happy to help you design a system. I know I personally go out on a lot of homes, to a lot of job site visits, and with contractors to evaluate and give suggestions. So your contractor development specialist is your friend. They will help you, and they have lots of information on what local regional standards look like. So that's kind of the long answer to that question. I hope that helps.
Chuck, any other questions that came in?
Yeah, we've got several questions in the Q&A. So the first one is from Marilyn. This is a great question. I'll read it for you, Frank, and then you can take it away. And essentially, she's asking if she needs help designing a zone system. Is there anything that we can provide to help her with that?
Actually, we have a lot of things to help her with a zone design. If she goes to Honeywell Home, forwardthinking.honeywellhome.com, clicks on products, clicks on zoning, there are videos that will help her. We also have product sheets and zoning cheat sheets that give them all the sizes of all the dampers, give them the kit numbers. Yeah, there's also contractor development specialist in Maryland that's very good. Reach out. I'm sure we can tell you who that is, and Jamie will get you that information, and I'm sure they can help you with your design.
Thanks, Frank. Next question from Antonio. He's asking, what is the proper method to properly adjust the bypass damper? This is a great question. We get this very often. It's actually very simple. The method that I use, and Frank may have something to add, but the method that I use is pretty straightforward. Once I have my system set up and my controls are engaged, if I'm using the HZ322 and the HZ432 panels, I can actually do this from the panel itself. So what I'm going to do is I'm going to just call for my highest stage of cooling. And I do it in cooling mode because that's when I'm going to get the most airflow through my system. So I call for my highest stage of cooling, and I am going to look at the bypass damper indicator and make sure that it is closed. And note, I'm calling for my highest stage of cooling with all of my dampers open. So all of my zones are calling. And the reason that I'm doing this is I'm trying to eliminate the zone system from the equation. So with all my dampers open, essentially I've eliminated my zoning from the equation, and I want to look to make sure that I'm not bypassing any air when that is the situation. And then once I have done that, I will then call for cooling in the highest stage for only my smallest zone. And in this situation, I am setting this, going from best case scenario to worst case scenario. And this is where I want to really set my bypass. So just to look out to make sure that we're good in the worst case scenario, I set my smallest zone, and then I want to make sure that my bypass is opening. The bypass damper, the way it's designed, is probably never going to open fully, but you do want to adjust it so that until it stops opening. And then finally, I'm going to go back to best case scenario, and then I'm going to look to make sure that it closed after I've adjusted it. If it doesn't close, then I'm just going to crank down on it just enough to where it closes, and then that will essentially be where you can stop. You can go back to your smallest zone again if you want to double check and make sure that it does open again. If you have trouble where you're going back and forth and you cannot get them to balance, you probably have you've done one or two things. You've either sized your bypass too small, or there is an issue with your ductwork downstream from the zone system. In which case, really, you're going to have to either tweak your bleed throughs on your dampers, or decide if it's acceptable to bypass a little bit of air when all of your zones are calling, because really at that point you're trying to make the best of a bad situation, because a lot of times I know that you can't really redo a customer's ductwork, so sometimes we just have to deal with stuff. So that's kind of my answer to that question. Frank, if you've got anything to add. I know regionally there are certainly differences.
Yeah, bypass questions are awesome. I love them because, to be honest, I was a stubborn contractor out there that did very high-end homes, and I always installed variable speed, multiple stage furnaces. And I'm not going to name brands, but I learned firsthand that if you go above 1.5 static pressure, that it does sound like a jet engine. And if you do high-end homes and you're trying to do really nice work, I mean, my work could be put in a museum, but I was saying to myself that I didn't need bypass because I had variable speed furnaces, but when I couldn't meet my cooling demand because my blower was ramping up, I typically, I would think like a contractor, I still do, but I would go in and adjust the dip switches to get the blower motor down, but then I have a compound problem. And the simple answer to that would have been bypass. And it wasn't until I came on board with Honeywell that I actually went out in the field and started discovering how important bypass is. And I hate to say this because I did really high-end work. I actually advised the people that took over my jobs to go back to these systems and install proper bypass. So yeah, bypass questions are great. And also bleed rate is very important, because a lot of those jobs that I did, if I had the actuators, I mean, so I know I'm showing my age here, so these are going back before 2014. But if I had bleed rates or knew how to adjust the bleed rates, That would have helped, but bypass is certainly critical on a lot of those jobs. And typically, this COVID thing is driving me crazy because I love to go out on site visits. I love helping contractors design zoning systems. And I know every one of my counterparts feels the same way I do. They love designing zoning systems. It's in our blood. Any other questions, Chuck?
Yeah, we do. So, so this one comes from Kevin. How do you deal with the return temps when you're bypassing 1400 CFM of conditioned air right back into the return? The Tex and I have discussed this. That would be a pretty good time to ask. And you're absolutely right, Kevin. It's a great time to ask. This is an interesting one. What I've found is that most of the time, if you are bypassing such a large quantity of air back into the return, what you're going to want to do is try to get your point of introduction, meaning where are you putting that bypass air back into the system? You're going to try to move that as far away from the heat exchanger and coil as you can. And I say as you can because there are certainly variables in that. Certainly you can't, you don't want to be, setting up a 35-foot bypass duct. Also, what I've seen is people will just take a full bag of flex. Down here in my market, we use flex duct a lot, which is sort of the bane of our existence, but it's great. But we use flex ducts a lot, and so essentially a 25-foot of flex, and they'll just basically attach that to the entire return. They don't cut it. And then they've got this long return duct, but it still reintroduces the air back into the return plenum. And I recommend that if you are having trouble with that you move that point back to a further away point. So you can either use a Y and then upsize your duct back into the return. So you could Y it back into another return duct. Or one thing that I've had a lot of success with, we have a lot of 2-story foyers and great rooms and stuff like that here in Georgia. And what we'll do sometimes is we'll put that bypass, we'll actually just put it back into a space, but we'll put it somewhere where there is no occupancy. So like a 2-story foyer or something like that. And then we'll co-locate another return. Oftentimes what we've done is we've put a large return and put the bypass and the return duct inside the boot for that return. So you're relieving pressure and you're reintroducing that air back into the system, and you're not changing the temperature of the air in the occupied space, but you're also mixing that air really well with the incoming return air. And that, so 9 times out of 10, that's going to solve your problem. So I guess the biggest takeaway there is just you want to mix that bypass air with incoming air so that you temper it so that it's not quite as cold or not quite as hot.
Yeah, and one of the things that we didn't go over that will alleviate that problem is, as Chuck said, now quite often we do have, 2-story foyers, or if we're in a light commercial setting, say an entrance, we'll set up a dump zone, which will alleviate the pressure so you don't if you have a dump zone, listen, you can take the CFM from a dump zone off of what you need for bypass, and it will alleviate the static pressure. But also the kind of elephant on this whole bypass situation is that all motors now are required to be ECM. So when we're dealing with older equipment, we're dealing with constant drive blower motors that, your bypass is gonna be open, say halfway when your smallest zone is calling. And if you've done it right, as soon as your second zone calls, you're not bypassing anything at that point. So then that problem goes away. So it's all about sizing your zones properly.
Yeah, I mean, I certainly agree with that. You know, no amount of technology, well, I don't know if I could say no amount, but very little of the existing technology that's out there can overcome a bad duct system. So, so I tell all my contractors, design work on the front end is paramount. If you're talking about, retrofit work, there are certainly, situations where our hands are tied and we kind of have to make the best of a bad situation. But design is my mantra. And then you'll actually find that you have fewer problems on the back end. So we have another question well, we have two more questions. We'll try to get to both of them. I'm not sure if we'll have time, but the first one is from Vinny. How do you properly install a humidifier in a zone system? We kind of touched on this, Vinny, and anybody else, but I just want to restate it. You want to essentially, I have a couple of different recommendations. First off, just kind of comically, what I would say is whoever is paying the bill needs to be the most comfortable. So, so if you've got, if you've got the situation where you have one humidifier and you want to make sure that person is the most comfortable, I would try to find out where they're spending the most of their time, and I would make sure that zone is certainly the priority zone. And so you could put that humidifier there. Short of that, really the more honest answer and the way that I typically design my systems is, knowing that humidity is a gas and it's going to fill the space, it's going to expand, and all of the humidity in the air is going to move from high humidity to low humidity. And that's just going to naturally happen, and there's really no way that you can prevent that. And to some extent, it actually will move through walls. It's certainly a lot slower. So, if you put that humidifier on the zone that is, what we would call the main zone, or the zone that runs the most, then you're pretty much going to cover your whole house, unless you have areas that are, closed off all the time. They may not be as well served. So think about that. But in most homes, you're just going to want to put it on the main zone. That's what we recommend.
Yeah, a good rule of thumb is pick the largest zone and know that the humidity is going to fill the space. There are other ways of doing it. We will cover those on applications and accessories next week. So keep that in mind.
Yeah, we're going to get a lot more into the weeds on some of those other things next week. So definitely try to join us if you can. Last question we have is about ECM motors. So let's see here. So I'm concerned about high temperature air across an ECM. I don't know.
Knowing that an ECM motor is going to ramp down, it's going to start up and it's going to check that it's not above 1.5, and it's going to ramp back down to 1.0. And at 1.0, your bypass damper should be closed.
Yeah.
That's a simple answer to that.
Yeah, that's a good comment. Actually, Bob, I apologize. This question came in through you. I think this question is beyond the scope of what we should be commenting here. If you want to have a conversation about that, then feel free to certainly reach out to your contractor development specialist, and they can try to answer that individually. Sure, we can.
Yeah, great follow-up there, Chuck. If we did not get to any of your questions here, we will be making sure to get that information to your Resideo sales rep to make sure that they follow up with you. Thanks so much to Frank and Chuck for answering today's questions, and thank you to Frank for providing the technical overview on our zoning products today. Please make sure to join us every week on Tuesdays at 2 p.m. Central Standard Time and Thursdays at 11 a.m. Central Standard Time for our Resideo Customer Webinar Series. And as both Chuck and Frank referenced, there is a lot of information to cover in terms of zoning. So we are going to go into zoning applications and accessories next week, and we're excited about those sessions. So please be sure to share those details with your teammates and coworkers and attend one of those 2 sessions that we are offering on the expanded zoning topic next week. And then we also want to make sure that you have access to our resource page that's been launched on the resideo.com website, where we post the recordings of our webinars. Please refer back to that website for recordings of these sessions and share those with your coworkers if they are unable to attend these live sessions. And then one final reminder to contractors who did not include your NATE ID on your registration form and you would like credit for today's session, please send your first name, your last name, and your NATE ID to homes.university@resideo.com within 1 week of today's live webinar in order to receive credit for attending today's live session. And then 2 final things to note: once our training session does end today, you are going to be prompted to complete a survey regarding our webinar session. Please take a few minutes to provide us with your feedback on that training that you participated in today. We are looking forward to offering additional webinar sessions going forward, and we do want to hear your feedback on today's session as well. And then finally, you are going to receive a follow-up email from us in a few days that includes some follow-up information along with the link to our new webinar page. Thanks all for joining us for today's Resideo webinar session on zoning. Please join us next Tuesday at 2 p.m. Central Standard Time as we dive into zoning applications and accessories. Thanks again for attending today's training session. Have a great day, everyone.